Hello there, I'm Thomas Hatsios, the pilot, captain flying the Boeing 777-300 ERX with PMTG simulations in tonight's flight. So thank you very much for joining me. I'm gonna show you how to use the Boeing 777-300 ERX systems, like the primary flight display with the airspeed and the barometric altitude above sea level, the radio altitude, the magnetic truth heading, the modes from the autopilot, connected, and the auto thrust, like the vertical and the lateral navigation mode, the pitch ladder, flight guidance of the flight director and the autopilot mode. Also navigation display with the airports, the waypoints, the world, the ADFs and navigation displayed, and also the flight plan created, the terrain displayed from the radar reflections, the terrain elevation, and also other information like the sea and the water around the terrain, and also on the magnetic truth heading, the wind direction and magnitude, and also the ground speed. And we have magnetic also truth heading in the navigation display. As also we have the autopilot flight director system panel. I'm going to show you how to use that with the autopilot and the dual auto thrust buttons. I'm going to show you the flight level change, the speed and DN1 mode, and the airspeed Mach switch selector for the selected airspeed and or Mach speed. So also we have the autopilot engage and the autopilot disengage switches. We have the heading select switch and button. We have also the lateral navigation and the vertical navigation of the flight management computer control display unit, CDU input for flight plan, lateral and vertical navigation, flight path around waypoints and fixes. In the GPS positioning of the navigation display, you will see them displayed as Mazzella line. The aircraft will have to follow with following it manually using the autopilot or manually. So this is the flight plan, flight path of the flight management computer. As you can see, we use it to create it using the aircraft information like its position and also the weight of the aircraft, empty weight, passengers and fuel, other things like the temperature here and perhaps I don't know, maybe I will show you later. So we also have in the autopilot flight director system, we have the vertical speed indicator and select button for vertical speed or flight path angle in degrees, and also we have the altitude select switch and button. We also have the FS panel electronic flight instrument system. We have, as I said, the auto thrust, dual auto thrust. We have in the overhead panel the ADIRU, the air data inertial reference unit, which displays in the primary flight display all the air data, barometric and anemometric altitude and angle of attack gyroscopic acceleration using gyroscopic lasers, and also magnetic truth heading using the magnetic compass, and also GPS, triple GPS position, which creates some IRS, as we call it, inertial reference system position. So, and also gyroscopic laser acceleration, deceleration of the aircraft, and a rate of turn. So we also have it displays all this information and feeds all this information in primary flight display, flight modes and anesthesia, and pilot and auto thrust, the FAREX, the full authority digital engine control computers that control the engines. So we also gonna show you I'm gonna show you the engines, the ACAS, the engine indication and crew alert system, the upper ACAS that displays mostly all the time the engine information, the lower ACAS will display additional engine information. So we have information about the engines, which is controlled by the FADEC, the full authority digital electronic computer. We have information of the N1, which is low speed, low pressure compressor stage of the engine, exhaust gas temperature, the N2, which is the high pressure, high speed rotor stage of the turbofan turbocharged engine. We have the oil quantity, we have oil temperature, we have the vibration of the N2 stage of the engine, of the turbofan turbocharged engine. We also have other things like in the overhead panel we have the electrical, the IDGs, the great drag generators and their conductors. Each IDG produces 75,000 kilovolts, 75,000 watts of electric alternate current, 400 Hz CPS frequency, 115 volts, and maybe this is converted using transformer rectifiers into direct current, and we can convert from the batteries. We have direct current all the time from the batteries. We can be converted into alternate current using static inverters, about 5.1 thousand kilovolts. And we also have the APU, the auxiliary power unit. We're gonna use the APU for starting the engines, and I'm gonna show you how to use it for having additional, maybe backup electrical power in case we lose anything. We have also 75,000 kilovolts from the APU. We have additional the hydraulic fluid pump from the left and the right engine. Also, the left and right engine has the IDG, the grid driver generator for alternate current, which is electromagnetic alternate current generator. We have the hydraulic fluid pump, which supplies hydraulic fluid to the flight control surfaces, like the ailerons, the spoilers, the elevator, the rudder, the horizontal tail stabilizer, trim position, the flaps and flap position, the landing gear expander track, the nose wheel steering, and the nose wheel, and also the parking brakes, normal and alternate, and the thrust reverser. So we have all these for the hydraulic fluid pumps and generators from the left and right engine. We have the backup electrical C1 and C2. We also have the rammer turbine, which can be extended in flight in case we lose the engine, to supply hydraulic and electrical and maybe pneumatic power. So we also have, as I said, the APU produces also pneumatic power. We need pneumatic for the engine start. Using the engine starter, we need compressed air. We need for the cabin pressurization, so we have the left and the right engine when the engines are working. Supply compressed air, 33 psi and higher. When in full power, maybe 60-70 psi for cabin pressurization, and also for hydraulic fluid, the tanks pressurization, and also air conditioning and wind and engine anti-ice system. We also have the cabin pressurization system with manual and automatic modes. I'm gonna show you, and we use the outflow valve controller to pressurize the cabin with climbing, or to pressurize it when descending. We also have the anti-ice system. We have the fuel tanks, left and right engine, left and right wing fuel tank. We have fuel quantity, forward and aft fuel pumps, and the center tank and forward and aft pumps. Then also the X-feed pump, X-feed valves actually, and the low and the high pressure fuel valves into the left and right engine. I'm gonna show you all these systems. We also have the thrust levers, the thrust reverse. We have the auto thrust connect and disconnect, and also the radio navigation communication panel, and this is most for the overhead panel. So I'm gonna start showing you the thrust levers, how to control the engine thrust, how to see some systems in the lower ACAS. The ACAS displays other systems, have a lot of information, has the computer display. So I'm gonna start showing you maybe the flight controls first. So you can see, thank you very much for joining me one more time. I'm Thomas Hatsios, the pilot flying the Boeing 777-300 ERX. So I'm gonna show you now the flight controls, the flight control stick, and I'll make an engine start demonstration very quickly of the Boeing 777-300 ERX. So you can see here we have the control column of the aircraft, the control wheel, which is the yoke of the Boeing aircraft, which is used to control which is used in the Boeing aircraft to control the flight controls. So for this I have this here in my home. This is the side stick I'm using, which is for the Airbus. So you use it for Boeing also. You can pitch up and pitch down the yoke or the elevator like that, and bank roll the ailerons and the spoilers, or the control wheel of the aircraft like that. You can use the rudder pedals this way, and also pitch up and pitch down the horizontal tail stabilizer of the aircraft. So we also have the thrust levers, excuse me. So you can see there is a direct input here between the two. You can see the control of the yoke here moving up and down, pitching up and pitching down. You can see the rudder pedals I'm using for the rudder. You can see the control wheel. So I'm gonna show you how to use this. We have the menu here, the displays. So we have the synoptics, we have the flight controls here. So you can see the left and right wing ailerons and spoilers, the elevators, and the rudder. So you can see here the autopilot panel. You can see other information, the ACAS. You can see the primary flight display, the airspeed and the altitude, barometric altitude, the radio altitude above the ground level. You can see barometric pressure, magnetic heading, the airspeed selected and the altitude selected from the autopilot system. We have the flight director on and the LNAV and the altitude. Here's the terrain around us. You can see the flight plan here, the flight path of the aircraft, some other aircraft flying. The airports, we can display the airports here. So if I'm creating this, you will see more information, a lot more detail actually. You can see Switzerland, Germany here, this side. You can see the flaps position, so I'm not having much time for explaining everything this slide. So you can see again the flight controls here, the control column and the control wheel. You can see how to control the aircraft like that. So we have the whole cockpit here. You can see an outside view of the Boeing 777. So I'm gonna show you now how to use the control stick here for the. You can see I'm pitching up and pitching down the aircraft, and also bang roll left and bang roll right, and also the rudder pedals. So we control the aircraft like that, pitch up, pitch down, bang roll left and right. It's identical to the Airbus aircraft. You can use it for the Boeing. So I'm gonna make the engine start demonstration now and try. I'm gonna make the engine start demonstration now and try to fly it out as much as I can. So thanks for joining me. You can see here flight control surfaces, ailerons, spoilers. You can see it's proportional to the side stick deflection, the flight controls movement of the ailerons and spoilers. So this is the outside view. Now I'm going inside the cockpit and I'm going to show you how to set up the flight plan and some systems and make the engine start demonstration. So here we go. Maybe not having all the time to show you. Here is the electrical panel, here is the hydraulic panel, here is the fuel panel, here are all the IDG, here is battery, the APU is on. You need to start the APU like that. Here is the on and off switches, the overhead panel. Here is the hydraulic panel. You can see you can turn on and off some switches here. This has to stay on. This is the fuel, the ADIRU, the air data inertial reference unit, the flight control computer, the engine starter, the fuel tank, This is the cabin pressurization. This is the air system, the pressurizer from the bleed system. So we have here the thrust levers. I'm gonna show you maybe very quickly and make an engine start. You can see this view of the aircraft. We have like maybe 35 minutes left for this flight. So we have the left and the right IDGs, the electrical power into the aircraft. We have the APU, we have the battery here on and off. This is the battery. It's important the APU start. We have the primary flight computers we need all the time. This is the Adiro, I'm gonna show you another time. Here that and also the reference unit. We have the window heat. This is the Boeing 777. So this is the hydraulics, left and right engine. Hydraulics, you can turn on and off all of them. There is a fault because you need to turn on. There is a fault too. So you can see the messages, hydraulic pumps, left and right engine, and C1, C2. So this is the fuel tanks, the sender enough. We have the cross feed on, so any pump can feed any tank if one pump is on at least. And here is the sender tank, right wing tank, left wing tank, about 20,000 kilograms each of fuel. We have the fuel dumps here. We can throw fuel into the air to make the aircraft lighter. This is the electronic engine control computer for the engine and the engine auto start system and selector. We have other systems like cargo fire extinguisher. We have the cabin pressurization system. Here is the auto, here is the manual. You can see the manual now on display. We need to use these controllers to pressurize the cabin climbing or the pressurize descending. So we press this back into the auto. We can also select the landing route in manual mode. So this is the left engine bleed air. This is the right engine bleed air. This is the APU bleed air. So this is a setup for engine start manually. So we're gonna reconnect this. Now we have pressurized air inside for cabin pressurization, hydraulic fluid pressurization, air conditioning, and other systems like maybe I forgot right now. So this is the autopilot panel, very important. How to use, how to set up maybe the airspeed higher for this flight. This is the airspeed selector. This is the heading. This is the runway heading here. 136 degrees is the bank angle limit. You can select this. You deselect the other switch, the L mount. Selecting the L, the heading select. Hold. You deselect another mode. So you can see how these buttons are depressible. Here's the auto thrust, left and right, the flight director on and off. We have flight director here. We have the vertical speed here. The altitude select. You can select a higher altitude for this flight. Then you press this button. Select maybe like 35,000, the vertical speed, flight path angle here. We need to change modes. So this is the autopilot connect. Now we have the autopilot connected here. You can see the primary flight display. You can see navigation display here. So we disengage the autopilot here. You will see the warning. The autopilot is off. We have the flight director back. So we connect this switch. This is the engine. You can see the strap produced by its engine. So we have the thrust levers here. We can move the thrust levers forward. You see N1 and the exhaust gas temperature increase. We have the C1 and CNR stabilizer electric trim cutout seats for the normal and alternate trim. We have the speed brake. We have the flap position here. We can select higher flap like 15 degrees, no 30 all the way down for takeoff. Other systems here like the auto brake, the landing gear. I will show you another times everything. More time. This communication panel. This is the parking brake, and this is the pit stream position. So this is the flight management computer here. Let me show you now how to make an engine start. You can see some other systems here. So you can see we have the door is closed and pressurizing the aircraft cabin, the gear. We have the electric left and right engine, C1, C2 backup. You see the green is the flow of the electrical power, alternate current is this side, direct current is this side, the battery. We have the APU alternate current also, the battery is here, the voltage. So we have the hydraulic, this is the left and right engine, compression of 3000 psi, supplies the flight control, line gear, parking brake, thrust reversers. You can see left and right engine and the backup in the supply line. The fuel, left and right wing tank, the fuel flow valves here. You can see the engine symbol, the fuel quantity here. The APU is also supplied. The center tank is empty, so we have about 17,000 and 16,000. We have the air system, the compressed air. We use this compressor from the engine. You have the left engine, the engine starter, the engine bleed, and we have green green line is supplied air like the electric and the hydraulic. The APU is no green line, is white because it's on. Green is on, but is off the line, the valves. So we have the valves open for the engine, the left and right engine. It's supplying right now. It's gonna turn on later. I'm gonna turn off. You can see the cabin pressurization, the air conditioning here of the aircraft. If we increase the thrust lever position like that, you will see also the cabin, the duct pressure increase. We have the arm, the down here for the speed brakes. We have other information. The CDU, the control display unit. So we go now to the flight controls again. So we have left and right flight controls. You can see the stabilizer trim. You can see the wings of the aircraft and the tail. Here the controls are moving. So we have also another couple of modes. We have the checklist here. We have a failure checklist computer. I'm gonna show you another time. You can see all the systems of the aircraft here in case of failure. What you have to do. Here's the normal menu, and before takeoff, before start, what you need to do. Complete the checklist. Every time something is happening, and checklist is complete here. So we go back into the status. We have the APU on, the hydraulic and the oxygen of the aircraft. So here's the engine. We have the N2. We have the N1 here, the exhaust gas temperature. I'm gonna show you right now these modes of the engine. So we go back into the virtual cockpit. We have like 30 minutes left for this flight. So I'm gonna show you very quickly how to make the engine start. How to set up the flight plan. So this is the M1, which is low speed, low pressure. Compared to the stage of the engine, just the information, the flaps position, We need flaps like 15 the exhaust gas temperature of the engine. This is the N2, which is the high pressure, high speed compressed stage of the engine, the fuel flow, oil pressure, or temperature, or quantity. So this information from the engine. When I move the thrust lever forward or backward, we have also the thrust reverse here. We reverse the thrust. So you can see all this information here displayed. You can see the thrust reverse, engage, and disengage. We have back normal mode for the thrust. So you can see the model of the aircraft here, Boeing 777. So this is the fuel cutoff switches. I'm gonna use this to turn off the engine. This is gonna take like a few minutes. We're gonna lose all the engine power now. Both engines are off right now. You can see the fuel flow here is 0. So we can start the engines later. So we also gonna use the flight plan very quickly. You can see if I come outside, you can see the Boeing 777 again. So you see both engines are slowing down the spinning. They're gonna stop. You can see also here the left wing engine is almost stopped. So we're gonna start now the overhead panel. Is having some reconfigurations in the switches. You get some yellow switches, some fault messages. So I'm gonna make the engine start here, the left wing engine first. So you will see the exhaust gas temperature, the N1, the N2, the fuel flow. Here is gonna to increase after the N2 is above 38%. You can see the left wing engine now start spinning. The right wing engine is off. So this is the engine start process for the Boeing 777 aircraft. So we have the left wing engine start here. So we start the fuel valves to the on position. So you're gonna have the fuel flow start running to the aircraft engine. So you can see here the spinner start increase spinning very rapidly, and we have the engine start. Here we go. So we go into the other engine, other view. Go inside again. Select the engine starter to the start position. You will see the bleeder from the APU start compressing the engine starter above 30% and 2. So we have the right wing engine now start spinning, but not yet fully started because there is no fuel flow here. It's only spinning from the pressurizer. So we go back in. We can start the fuel flow now. The fuel valve. So we have here fuel flow is 0 for the right wing engine. You can see now it's increasing. So we have the fuel flow into the right wing engine, and it's gonna start spinning too. So here we almost start the right wing, and here we go. It's ready. So we go into the other side view again. Coming this side now. Make a very fast flight plan creation. Very fast. So we have not much time to explain for this. So You can see the initial, we have the position here, and then position is already here, Lszh. So this is for the air data inertial reference unit alignment, set tire inertial position. So we go to the initialize, zero fuel weight and gross weight, and the fuel cell is 2,800 kilograms, flight level 25,000 feet for this flight, and the cost index 100. The temperature and the cruising center of gravity, the reserves, the thrust limit, we have the route from Lszh to Lszh, the runway 14. Now we have departure and arrival 14, transit to Alpha, and arrival ILS14, transnegular for transamity. We have the legs, we have this one here, and activate and execute, and we have the whole flight plan. We only need to set its flap sphere position, the center of gravity of the aircraft for takeoff, the takeoff reference, and the V-speeds V1, V-rotate, and V2, with the gross weight and the center of gravity position here, trim for the horizontal tail of the aircraft. So it's 4 degrees upward. So we have the flight controls here, and we're ready for takeoff. We can have the flight plan here displayed. So we have the LNAV here engaged for takeoff if we want. We have, yeah. So we only now have to do, we're ready for takeoff now. To proceed into the runway, as you can see. We have like 20 more minutes for fly, 20-25 minutes. So this is not gonna be a very big flight, so just disarm the parking brakes here, move the thrust levers forward, advance the thrust, and use this tiller here to steer the aircraft. You can see how I'm steering with this wheel. This is the nose wheel steering of the aircraft. So a little bit more thrust here from the thrust levers. Not too much. And a little bit more nose wheel steering. For steering into the runway. So the runway is empty. We can, there is no traffic actually, so we can use it for takeoff. We have the correct flaps for takeoff, and the autopilot is set correctly. This is our position for takeoff. So you can see we have the flight plan here line, the ground terrain in front of us. So we're gonna fly with these modes here. Just 1 second. So this is our position to the airport. The runway here. You can see the other runway beside us. So this is the Zurich airport. We're gonna start right now. We have like 35 more minutes to go for this flight. You can see this is the Boeing 777 here. I want a nice view for this takeoff. So we advance the thrust levers forward. You're gonna see the engine thrust increase. We have the autopilot panel set normally for takeoff airspeed and altitude and heading. So you can see here we have the flight director and the pitch ladder, the flight guidance for the aircraft. Radio altitude, airspeed are selected. Altitude, heading, select the primary flight, display flight mode and non-schedule. You can see the barometric altitude above sea level, the magnetic through heading and the barometric pressure altitude. So I'm gonna show you now the advanced thrust levers even forward to the maximum takeoff ground. And disarm the parking brakes here and go. So we have like 25 more minutes for this flight. We have 100 knots right now. 100 knots. So we have V1, V2, V rotate. So here we go. We have both rate of climb off. Retract the landing gear. So you can see here we have the radio altitude. This is the distance from the aircraft to the ground. This is the distance from the aircraft to the sea level. To different altitudes. 2,400, 500 feet, 4,000 feet above the sea level, 5,000 feet per minute rate of climb. You can see this needle moving up. You can see this display. The airspeed selected. The airspeed right now 200 knots and increasing. This is the flight plan. This is the runway, the terrain in front of us, green, red, and yellow. So we fly manually right now. This departure, keep climbing, no problem with that. You'll see an outside view now. Have like 20 more minutes for this flight. So this is the Boeing 777-300 ERX after this takeoff. We need to climb a little bit further. Hope you like this aircraft. So you can see the climb bout, you can see Switzerland. You can see the star sign here. We have like maybe 20 more minutes to go for this flight. So we're gonna fly over manually and fly over we have to trim up this switch here, trim up a little bit, trim this position here. So we're gonna use the LNAV one more time, direct to so this is the next waypoint, the Zui, so we have to fly direct into the Zui. Execute, flying direct, and after that is the next waypoint. As you can see, 15,000 feet, maybe need another couple of minutes to climb to the maximum. This is, and then come back for landing. Then we have like 15 maybe more minutes to go. 16,000 feet. So use maybe a little bit more airspeed, I'm not sure. Use manual thrust input. We need to climb higher faster. We're gonna retract some flaps later. So this is the way of flying this aircraft. Maybe not standard flight, but you can use it. As a training flight or a test flight, like trying to test this aircraft. So we have about 20 more minutes to go. You can see the lake here we have. So this is the Boeing 777, beautiful views here. Keep climbing, we are 20,000 feet right now. We almost reached our maximum altitude for this flight, 35,000 feet, and we're gonna have the handrails in a while. So you can see we overfly this lake. Just how beautiful this aircraft wings are. Huge wings and engines here. You can see we overfly the Alps region. So this is the Boeing 777, how smooth flying is, 31,000 feet. Have a few more minutes to go. 32,000 feet, quite higher. So showing you inside one more time. Keep gliding up, flying manually. Having like maybe 46. Yeah, like 15 more minutes for this flight. 5 minutes. Next, 22,000 feet, 33,000 feet, keep climbing up. We passed 33,000 feet, keep climbing up a little bit more. We have 5 minutes left for this flight. So this 33,000 feet passed, and we have the chemtrails now. This is the frozen exhaust from the aircraft. We have minus 37 degrees maybe here, and freezes the exhaust gas from the engine. We also have the star sign here, 34,000 feet. So now we are almost 7,000 meters above the earth, flying quite fast with about 600 kilometers an hour. Mach 0.5 here, 200 knots. And here we are in the cruising altitude, 25,000 feet. Cruise a little bit here, maybe retract some flaps. We don't need so many flaps here now. We need to increase the airspeed. So you can see I'm using some manual input here to control to stabilize the aircraft at this altitude. So we hold stable 35,000 feet with this airspeed, ground speed Mach 0.55. You can see the flight director and the limits of the aircraft. So we go turn back into the airport. So you can see we have maximum thrust now. Keep flying. So here is the altitude. You can see the fumes of the aircraft. $35,000 feet. So this is how fast we go, Mach 0.7. Now we have to, we're flying Germany now, the Bayern Munich area, and this is the Munich and Bavaria region. 36,000 feet right now, 100. So we go back into the airport now, overflying Germany and Switzerland. You can see how beautiful Germany is in front of us. So going back into the airport now, making the turn. You can see this valley is Germany here. Trying to input some manual flight control. Going back into our airport. We have a beautiful, you can see the areas, the stratosphere here. This is the troposphere and the stratosphere of the Earth. This is how high we are right now and how fast. 36,000 feet. 36,500. Maybe connect the autopilot in a while, just making the turn. You can see the airspeed. We have a few more minutes to go. 15 more minutes. So we stabilize the aircraft here. This is how beautiful this overflying Germany and Switzerland. Bavaria here. So this is taking the turn here over. You can see the fumes from the engines here, the exhaust. This is how beautiful Germany is at night, and Switzerland. So here we go. So this is the night flying. We have the galaxy above us. Beautiful flight. You can see the star sign. 27,000 feet now. 300. Reach a higher altitude here. So we have the galaxy here. Beautiful star sign. So this is the spacecraft for tonight, the Boeing 777-300 ERX, our spacecraft in this shuttle flight from Zurich back to Zurich. We overflying the lake again, this beautiful lake in the mountains. So we go back home. You Let's see this view. Oh, we have to turn back into the airport, make another turn manually. You can see the scan here from the ground and the weather maybe in this altitude. So we go down to a lower altitude now, and we have to fly direct into the airport right now. Take another turn. So this is the autopilot panel. We have to descend a little bit lower and make a connection here. We're gonna connect the autopilot now. So this is the autopilot flying. Select this altitude here and maybe a higher airspeed for flying, like Mach 0.75. So we will need to make a correction here, flying direct into this one thing. So execute. $35,000 feet. Retract some flaps, increase the airspeed. Now we have the autopilot and the autothrust connected. So this is gonna be an autopilot and autothrust flight. We have like maybe a few more minutes to go for this flight, overflying again Germany here in Switzerland. And we have like 15 more minutes to go. $34,000 feet, 42 nautical miles away. So we need to descend lower now into this flight level. Lower the flight level. 33,000. So we're gonna use the vertical speed flight path angle. This is how fast we need to descend actually, like 2,900 feet per minute. With this maybe Mach speed. So we go with Mach 0.773. We're gonna be like 10 minutes in the airport. Quite fast. 10 minutes for the airport, Mach 0.74. 31,000 feet here. Keep descending. We're going very fast now into the airport. Now we overspeed. So we need to take some speed breaks. Now reduce the airspeed a little bit. $36 nautical miles. So I need to make only one last input for this, the descent airspeed, approach airspeed and flap setting for this aircraft weight and settings, because weight you can see. So we have the legs here. Maybe we're gonna use another one input. Σε λίγο, σε 5 λεπτά. Have to use a couple more inputs here because 15,000 feet going very fast now with Mach 0.69, about 700 kilometers an hour, just 5,000 meters above the sea level, 4,000 meters above the ground level. So this flying with 700 kilometers an hour right now. So we have the runway on this side, we have the airport here, we're gonna see it in a couple of minutes. So we're gonna use a manual flight after that. Disconnect. You can see the autopilot is connected now, so we disconnect it. We fly manually 12,000 feet. We have last waypoints here. We have the flight guidance, 600 kilometers an hour now, airspeed. (10,000 feet). You can see the radar scan now. We have a beautiful radar scan for the ground level. So the green is the lower than the aircraft, ground level. We have the river in front of us, so we're gonna start using the mode, maybe decrease the airspeed a little bit here to a more manageable level. Like 200 knots is enough, so we're gonna slow down the aircraft now. You can see the thrust levers are at idle. Automatically you can see the level of the N2 and N1. Keep descending. Cross the flight, the river here. We're gonna use connect the autopilot now. Use some landing gear here. So we're going to fly director. We use also this switch here, the flight level. So we cross 6,000 feet now. We're flying manually. We have to slow down a little bit our aircraft. You can see the runway on this side. We can start making corrections for this flight. This is the descent path here. We have to input some manual yoke controls, so we can start turning into the runway. We can also add some flaps here. Control the airspeed manually also. So this is turning into the runway now. We're very close into the runway. Just 5 minutes away, so we can see the Lszh localizer is on right now. We also have to decrease the airspeed a little bit. So more manageable landing airspeed. You can see we have the guidance here, the vertical guidance and the horizontal guidance. We can add some thrust if we want manually, just to go a little bit faster into the airport. So we have the river in front of us. We can also add some flaps, some more flaps here to have better maybe stability for this low climb. We also need that whole level now. So you can see the localizer here, the vertical glide slope, this magenta symbol, the Lszh localizer, the distance to the ground 2,000 feet right now. So we need to hold our level here for a while, just to align with the runway heading. So we are quite closer into the runway now. We're very close to the terrain level. You can see how close we're flying into the ground. So we don't need to align a little bit. We're flying a little bit lower than the glide slope. We need to hold the whole level here. So you can see we stopped descending now. We have the airspeed here. You can see all the information we need for the Lszh localizer landing. So we have the Lszh localizer online now. You need to hold a little bit higher. We can see how close into the ground we bring the Boeing 777, but no problem. We're gonna have the landing flare now. So we need only a few more meters to go, a few more feet. $200, $100, $50, $30, $20, $10. So this is the flare of the aircraft. We just touched down. So we use the parking brake, the landing gear, the reverse thrust. So that was a nice landing. It was a little bit offset the runway into the edge of the runway, but it's okay. We have no failure in anything. The aircraft is completely safe, as you can see. The landing gear and the nose wheel. So I will turn on landing lights here. Disarm the parking brake and move a little bit forward. You can still steer the aircraft, as you can see. Τώρα φεύγω, περίμενε. Καλά, εσύ.
Δεν δουλεύει σήμερα.
Θα σου πω.
Τι άμμο πεις, είναι 7 η ώρα.
Ναι, εντάξει.
7 και 5. Αυτό που κάνεις δεν πρέπει να το κάνεις. Άμα δουλεύεις, μας σου πει να σηκώνεις να πηγαίνεις νωρίς στη δουλειά σου. Μην κάνεις με το φάκι το κοπιό τελευταία στιγμή, ας το διώξεις και τραβάς μετά τα μαλλιά.
Καλά, εντάξει. So that was the whole flight of the aircraft. I hope you like it. You can see the landing gear is safe and the nose wheel. You can see the nose wheel here and the landing gear, the tires, everything's safe. The wings of the aircraft. So you can see everything is ready for takeoff ground mode. The flight director, we have no damage into the aircraft system. So if I'm gonna show you inside, you can see there is no message. So that was Thomas. Hatsios, the pilot captain flying the Boeing 777-300 ERX into tonight's flight. Thank you very much for watching me. I'm gonna see you next flight. Bye bye. That was Thomas Hatsios, the pilot captain flying the Boeing 777-300 ERX. Thank you very much. Bye bye. Well, actually, I forgot to mention. I forgot completely to mention this. Forget about it. So that was Thomas Hatsios, the American British pilot flying the Boeing 777-300 ERX in tonight's flight, the PMDC simulation flight aircraft. So thank you very much for watching me. I'm gonna see you next time. Bye bye. Bye.